Hello everyone, welcome back to Lemon Code 21. In this session, we will learn Dockerfile. This is the material that we will discuss in learning the Dockerfile. In the beginning, we learned the basics of using Docker, and we also explored various features such as creating containers, port forwarding, using environment variables, and more. In the Docker Basics class, we have learned a lot about how Docker works, from using Docker images to creating Docker containers. Now, what if we want to create our own Docker image? Creating a Docker image can be done by using instructions that we store in a Dockerfile. A Dockerfile is a text file that contains all the commands we can use to create a Docker image. Let's assume that we store all the instructions to run our application in the Dockerfile, and later on, the Dockerfile will be executed as commands to create a Docker image. To create a Docker image from a Dockerfile, we can use the Docker Build command. When creating a Docker image with Docker Build, the image name is automatically generated randomly. However, we often want to add a name tag to the image, and we can modify it by adding the T command. Here is an example of how to use Docker Build T image name tag folder Dockerfile. Dockerfile format. As the name suggests, Dockerfile is typically created in a file named Dockerfile without any file extension. Although it is technically possible to use a different name, it is recommended to use Dockerfile as the file name. Simply put, here is the format for a Dockerfile comment. instr uction arguments. The symbol is used to add comments. Any code on that line is automatically considered as a comment and is not executed. instr uction represents the command used in the Dockerfile. There are various instructions available, and the command's case is insensitive, meaning you can use either uppercase or lowercase letters. However, it is recommended to use uppercase letters. Arguments refer to the data arguments for the instruction. The arguments vary depending on the type of instruction being used. From instruction. When creating a Docker image, the first command is usually to define the build stage using the instruction from. From is used to create a build stage based on the specified image. It is uncommon to create a Docker image from scratch. Instead, we typically build it from an existing Docker image. To use from, we can use the following command from image version. Where image refers to the name of the base image and version represents the specific version of the image. Okay, let's open our IDE. Here, I'm using Visual Studio Code. To create a Dockerfile, we just need to create a file named Dockerfile. As we've discussed before, to create a Dockerfile, we use the from instruction followed by the image name and tag. Let's try using the Alpine image with the latest tag. Alpine is a lightweight and simple Linux distribution based on MutliStage and BusyBox. We have created it. Next, we'll create a note file in Markdown format as a note. Let's create it. I'll write it in the notes so that we don't have to rewrite it in the terminal if there's an error. The next step, we will create a Docker image with the following script. There seems to be a mistake. It looks like we don't need to use a dot. Let's try again. And there's still an error. Oh, it's because I haven't started Docker on our computer yet. Let's run Docker first. Done. We have started Docker. Now everything is running smoothly. Next, we see the Docker image that we have created. Okay, the Docker image has been created with the from tag. Run instruction. Run is an instruction used to execute commands within the image during the build stage. The results of the run command are committed as changes to the image. This means that the run command is executed only during the Docker build process, and once the image is built, the run command is not executed again. When we run a Docker container from the image, the run command is not executed. It is used primarily for tasks such as installing dependencies, configuring the environment, or running scripts during the build process. The run command has two formats. Run command. This format allows us to execute a command directly in the shell within the Docker image. Run executable argument. This format is used to execute a command using JSON array syntax. It is often used when the command requires special handling, such as when using shell features like globbing or when passing arguments with spaces. All right, let's create the second folder and run the instructions as usual. First, let's create the note file. Before we create the Docker file with the run instruction, let's decide what we are going to do. First, in the run instruction, we will create a folder named hello inside the Docker. Second, we will create a file inside that folder and write hello world in it. Great, we've created the steps. Now let's write them in the Docker file. Here's the script that consists of from and run instructions. Next, we'll create the Docker image. Let's check the Docker image. The Docker image has been successfully created with the name lemoncode21 and the tag run, as we can see in Docker Desktop. Command instruction. Command or command is an instruction used when a Docker container is running. Command is not executed during the build process, but it is executed when the Docker container is running. In a Dockerfile, we cannot have more than one command instruction. If we add multiple command instructions, only the last command instruction will be used to run the Docker container. In a Dockerfile, we cannot have more than one command instruction. If we add multiple command instructions, only the last command instruction will be used to run the Docker container. It's important to note that command can be overridden by providing a command when starting the container using the Docker run command, or by using the CMD option in a Docker compose file. The CMD instruction in Docker has several formats. 1. command param. This format specifies the command to be executed along with its parameters. It is similar to running the command directly in the terminal. 2. command executable param. This format specifies the executable and its parameters as an array of strings. It is commonly used when the command or parameters require special characters or spaces. 3. param. This format is used when the command should be the default command defined in the entr Entrypoint instruction. The parameters specified here will be passed as arguments to the entrypoint command. Alright, let's create the third folder with command instructions as usual. First, let's create the note file. In the process of the CMD instruction, we will try to create a command to open a file inside Docker when it is run. For the initial steps, we will still do the same as the Dockerfile using the run instruction, but later on, we will add the copy command and then add the copy command to open the file. Before we continue, let's list the steps. First, create the image. Second, create the Docker container. Third, start the container. Then, inspect the container. Okay, let me type first in the note for the steps for making the Docker. Okay, let's write down the steps and execute them. First, we've created the image. After building, we check the Docker image via Docker Desktop. The result is that there is already Docker Lemon Code 21 with the command tag. Next, let's just copy the script. Alright, the container is now ready. Next, run the container. Then let's check the logs. The result shows that we have successfully executed the command instruction inside the Dockerfile. Let's try to run the Docker again and see the results in the logs. Label instruction. The label instruction in Docker is used to add metadata to the Docker image that we create. Metadata refers to additional information such as the application name, creator, website, company, license, and more. This metadata is useful for providing information about the image, but it is not used when running the Docker container. The label instruction allows us to add key value pairs to the image's metadata. These label S can provide descriptive information or serve as tags for categorization. Labels can be accessed using the Docker API and are commonly used for organization, documentation, and identification purposes. It's important to note that the label instruction does not affect the functionality or behavior of the Docker image or container. It is purely for informational purposes and helps in managing and understanding the image. Here is the format of the label instruction: LAB EL key value. LAB EEL key 1 value 1 key 2 value 2. This format is used to define key value pairs for adding metadata to the Docker image. Each key value pair represents a specific label with its corresponding value. Multiple labels can be defined by separating them with spaces. Alright, let's create the fourth folder with label instructions as usual. First, let's create the note file. Writing labels is quite simple. You just need to provide the key and value. For the rest of the steps, the process is similar to the previous Dockerfile. We'll just add the label instructions. The labels we will add are author, YouTube, and website. Next, let's build the image. After building it, we will inspect the Docker image. If we check the label properties, we should see the author, website, and YouTube labels that we added. This is the purpose of the label instruction in the Dockerfile, to add information to the metadata of the Docker image. Duction. The add instruction is used to add files from the source to the destination folder within the Docker image. It can detect if the source file is compressed, such as tar, gzip, gzip, and others. If a compressed file is detected, it will automatically be extracted into the destination folder. The add instruction also supports adding multiple files at once. The add instruction has the following format: add source destination. Example: add world, text, hello. Adds the file world, text to the hello folder. Add, text hello. Adds all, text files to the hello folder. Alright, let's create the fifth folder with the add instruction as usual. First, let's create the note file. In the process of the add instruction, we will try to create a command to add a file to the Docker. For the rest of the steps, the initial process is the same as the previous Dockerfile. We just need to copy and then add the add instruction to add the file. Before continuing, let's define the steps in the Dockerfile. In the Dockerfile, we will create a folder named myfolder and add the word text file from our folder. Next, we will check the contents of the file. The steps to build the Docker image are still the same. We just need to copy the script. The only difference is that we will change the tag name. Let's directly create the Docker file. Here, because we want to add word text, let's create that file first inside our fifth folder. After that, we can build the Docker image and then create the container. So, let's create the Docker file first. If you want to add all files ending with text, you can simply add an asterisk after the text. This wildcard symbol will match all files with the text extension in the specified directory. Now we build the Docker image. Next, we just need to copy the script. The container is already there. Next, run the container and check the logs. The result is that we have successfully executed the command instruction in the Dockerfile. The container has been created. Now let's start the container. Lastly, let's check the logs of the container. As you can see in the log, we have successfully opened the Word text file with the content "Hello everyone." Copy instruction. The copy instruction is used to add files from the source to the destination folder in the Docker image. But what is the difference compared to the add instruction? Copy only performs file copying, whereas add can not only copy files, but also download sources from URLs and automatically extract compressed files. However, it is best practice to use copy whenever possible. If you need to extract compressed files, it is recommended to use the run command and execute the appropriate application or command to extract the files. The copy instruction has the following format: copy source destination. Example: copy world, text, hello. Adds the file world text to the folder hello copy text. Let's create a new folder named Instruction for our next task. As usual, let's start by creating a new note file to outline the steps. The process for the copy instruction is quite similar to the add instruction. The only difference is that we will use copy instead of add to copy files. Here I have written down what we will create: a Docker file. First create a folder and copy the files, and lastly read the files. The running steps are still the same. All we have to do is change the tag now to copy. Before we proceed, let's list the steps. Build the Docker image. Create a Docker container. Start the container. Inspect the container. In the Docker file, replace add with copy instruction and add a new text file. Now we create a text file that will be copied to Docker. Execute the commands. Let's begin by building the image. Then creating the container, and finally checking the container logs. If we open Docker Desktop, we should see the new text file inside the container. dockerignore file. When we use the add or copy instruction to add files from a source, Docker first reads a file named dockerignore. This file functions similarly to the gitignore file, where we can specify which files we want to ignore or exclude. If a file is mentioned in the dockerignore file, it will be automatically excluded from the add or copy operation. The dockerignore file also supports ignoring folders or using regular expressions to specify patterns to be ignored. Let's create the 7th folder named dockerignore, just like how we usually create a new folder. First, we will create a file called note in the folder. Basically, the dockerignore file functions similarly to the gitignore file. The dockerignore file is used to inform Docker about the files and folders that should be ignored during the image building process. We can simply copy the notes that have been created for the steps to build an image and container. We just replace the tag with ignore. As an example, we will create a folder named text with a subfolder named temp inside it, which we want to ignore. We will add this entry to the dockerignore file. We have created the required files. In dockerignore, we write which folders or files will not be executed into the build image. We continue to write the Dockerfile. Okay, let's just execute the Docker step. You should see that the temp folder is not included in the Docker image. Expose instruction. Expose is an instruction used to indicate that a container will listen on a specific port and protocol. The expose instruction itself does not actually publish any ports. It serves as documentation to inform those who create Docker containers that this Docker image will use a specific port when it is run as a container. The expose instruction has the following format: expose port. It uses TCP, expose port CKey, or expose port UDP. Create an 8th folder named expose as usual. In this folder, create a file called note first. Copy the notes from the previous Docker creation and change the tag name to expose. This will be the guide for the next steps in the expose process. In this expose process, we will create a simple service using Node.js Express. The first step is to run the command yarn init to create a new service. Fill in the required information such as name, description, and others. After the initialization is done, add a simple script in the package JSON to run the service. OK, now we add the Express dependencies. Added a start script that points to the index.js file. In index.js, we create a simple service like home router. Create a Dockerfile command for our Docker container. For this step, create a new folder named app and copy the package JSON file from the previously created service to the app folder. Next, install the node modules with the npm install or yarn install command inside the app folder to install the required dependencies. Finally, run the service with the command that has been added in the package JSON script, ensuring that the expose port is 3000 as required for the Node.js Express application running inside the container. Make sure to add the node modules folder to the dockerignore file to prevent it from being copied into the Docker image, as node modules is large and should be generated through the installation process inside the container. Now we build the image and container. Just execute the script that we made in the note. Oh, is an error folder not found? Let's fix it first. To verify that the port has been successfully exposed, we can inspect the Docker image that has been created. If needed, we can ensure that the exposed port is 3000. These are the steps to create a Docker container with the feature of exposing port 3000 using Node.js Express. Hope it helps. Environment Variable Instruction. NV is an instruction used to modify environment variables, either during the build stage or when running inside a Docker container. Environment variables defined in the Dockerfile can be reused using the syntax env name. The environment variables created using the env instruction are stored in the Docker image and can be viewed using the Docker image inspect command. Additionally, the values of environment variables can be changed when creating a Docker container using the Docker container create env key value command. The format for the env instruction is as follows: env key value or env key 1 value 1 key 2 value 2. This instruction is used to set environment variables in the Docker image. Each key value pair represents an environment variable, where the key is the name of the variable and the value is its corresponding value. Let's create the 9th folder about environment. As usual, we'll start by creating a note file first. For the Docker creation steps, we'll copy them from the previous process and change the tag name to NV. We'll also copy the previous Docker file to simplify the process. We'll add an environment variable called dapp_port with a value of 8080 and replace the occurrences of 8080 with the variable eapp_port. For the app service, we'll copy it from the previous node, JS Express application. Now, it's time to execute the Docker image and container creation. Just copy the one above, then add the NV with the app_port property equal to 9090. Slightly modified port replaced using NV port. We create a second container with NV port 9090. Let's build image. After that, we'll inspect the container with the environment tag, which by default exposes the app on port 8080. Now, we'll try creating another container by modifying the exposed port to 9090. Now we create the second container. We have to run the container. If we check the list of containers, there will be two containers. One container with the default port, 8080, and the other container with the exposed port changed to 9090. Upon inspecting the containers, we will see that each container has two ports, one with the default 8080 and the other with the modified exposed port, which is 9090. Volume instruction. Volume is an instruction used to create a volume automatically when creating a Docker container. All files within the volume will be automatically copied to the Docker volume, even if we didn't explicitly create a Docker volume when creating the container. This is particularly useful when our application saves data in files, as it ensures that the data is automatically stored securely within the Docker volume. The format for the volume instruction is as follows. Let's create the 10th folder about volume instructions. As usual, we'll start by creating a note file first. For the Docker creation steps, we'll copy them from the previous process and change the tag name to NV. We'll also copy the previous Docker file to simplify the process. We'll use yarn init to create the service and then add a simple script. In this process, we'll make some modifications to the node, J's Express application. We'll add a new route, getById, which will write a word based on its ID value and store it in a text file. Let me write the steps first. Here we create a variable appData, which will be retrieved from the Docker volume. Let's create a variable to define the content and the path name. We make the process of writing a file. Now, let's create the Docker file by copying from the previous one. After that, we'll add a volume instruction named a ppdata with a folder named logs in it. We'll place the volume instruction below the expose instruction. Okay, let's execute the build and create the Docker container. We will check using Docker Desktop. If the Docker container is running, we should find Tholog's folder with files inside it. Now, it's time to test. If we make a request to Halland, in the URL, there should be a file named Halland. Okay, that's correct. Each time we call getById, a file will be created based on its ID value. Working Directory Instruction. Workdir is an instruction used to set the working directory for any subsequent instructions such as run, compt, entrypoint, copy, and add. If workdir does not exist, it will be created automatically. Once the workdir is defined, it becomes the location where the subsequent instructions are executed. If the workdir path is a relative path, it is automatically relative to the previous workdir directory. Workdir can also be used as the initial path when entering the Docker container. The format for the double UORKDIR instruction is as follows. First, create a new folder named workdir. Create a file named note as usual. Copy the contents from the previous note file as a template. Then replace the tag name with workdir. Also, copy the node J's express code and change its tag name to workdir. Next, change the first run command used to create the file to workdir. Then, remove the process of changing directories, since we are already using the workdir command, and proceed to run yarn directly. Execute the Docker build and container. Run the created Docker container. Check the list of Docker containers to verify if the container is running. Perform an inspection of the container to ensure that the working directory is pointing to the app folder. Use the docker exec command for this. We use docker exec to see if the workdir is already in the app folder. If you want to confirm that the working directory has been changed to app, type the pud command inside the container. By following these steps, the Docker container will be ready to run with the specified working directory app. User instruction. User is an instruction used to change the user or user group when the Docker image is run. By default, Docker uses the root user. However, in some cases, there may be applications that should not run as the root user. In such cases, we can use the user instruction to change the user. The user instruction has the following format. Let's create a folder called 12 with instructions for setting up a user. As usual, we'll start by creating a note file. For the steps related to Dockerfile creation, let's copy them from the previous instructions. We'll create a new Dockerfile and copy the contents from the previous one, making sure not to forget the node J's express code. Now, let's proceed with adding a user to the Dockerfile. First, we'll create a new group inside the Linux Docker. Here I will add a user. Afterward, we'll provide access permissions to the user and the group in the app folder. Finally, we'll change the user to the one we created. We just copy the Node.js service. Just execute the Docker build immediately. There is an error here. I forgot I haven't changed the tag node to Alpine. Another error. Oh yes, because the wrong command should be educer. Okay, it worked. It's time to create a Docker container. Then start the container. Let's try to inspect the container to see the user. The result is that the user has used the myuser that we have created. Argument instruction. Arg is an instruction used to define variables that can be passed by the user during the Docker build process using the build arg key value command. Arg is only used during build time, meaning it is not used when running in a Docker container, unlike env, which is used when running in a Docker container. Accessing variables from arg is done in the same way as accessing variables from env, using variable name. The arg instruction has the following format. Arg key creates an argument variable. Arg key default value creates an argument variable with a default value if not provided. Let's create a folder named 13th with instructions for using arguments in the Dockerfile. As usual, we'll start by creating a note file. For the steps related to Dockerfile creation, let's copy them from the previous instructions. Time to change the name tag. We'll create a new Dockerfile and copy the contents from the previous one, making sure not to forget the node. J's express code. Next, we'll remove some instructions from the Dockerfile. Now we'll add an argument instruction. Here, we'll create an argument called node version with a default value of 18, which can be called later in the tags. Additionally, we'll replace the rune instruction with workdir to make it easier. After that, we'll copy the node. J's express code as well. Now we can proceed to execute the command to build the Docker image. Once it's done, we'll perform an inspection of the Docker image. The Dockerfile will be using arguments, and the environment variable node version will be set to the default value of 18. Health check instruction. Health check is an instruction used to inform Docker how to check whether a container is still running properly or not. If a health check is specified, the container will automatically have a health status, starting with starting and then transitioning to healthy, if successful, or unhealthy, if it fails. Here is the format for the health check instruction. Health check none. This means the health check is disabled. Health check options command. This option specifies the time interval between consecutive health checks. The timeout option sets the maximum time allowed for each health check to complete. This option defines the time period Docker will wait before starting health checks after a container has been created. The retries option determines the number of consecutive health check failures allowed before considering the container as unhealthy. Let's create the 14th folder with instructions for implementing a health check. As usual, we'll start by creating a note file. As previously discussed, to define a health check, we simply need to specify the health check instruction with the interval, timeout, and start settings. We'll create a new Dockerfile and copy the contents from the previous one, just changing the tag to health. Don't forget to also copy the node J's service code. Now, we'll add a new router named health, which will perform a simple counting logic and return a response of 500 if the count exceeds 5. Moving on to the Dockerfile, we'll copy some instructions from the previous Dockerfile. And add a run command to install curl inside the Docker container. After that, we'll include the health check instruction in the Dockerfile, specifying the interval, start period, and using curl localhost. As one of the commands. During the Docker image build process, there might be an error since a curl cannot be installed. To resolve this, as we are using Node J's version Ubuntu, we need to replace the installation command with apt-get. Once we have fixed the issue, we can proceed to build the Docker image and container. After starting the Docker image, if we check the list of Docker containers with the Docker container ls command, we can see that the status of a container can be marked as unhealthy if it returns a 500 error response, which we have set in the application code. To view the log output of the health check, we can use the Docker container inspect command. By following these steps, we have successfully implemented a health check for the application running inside the Docker container. Always perform the steps carefully and follow the instructions thoroughly to avoid any mistakes during the Docker image and container creation process. Good luck! Entrypoint Instruction. Entrypoint is an instruction used to specify the executable file that will be run by the container. It is often used in conjunction with the CMD instruction. When the CMD instruction does not specify an executable file, it will automatically use the Entrypoint instruction. Here is the format for the Entrypoint instruction: Entrypoint executable param1, param2. Entrypoint executable param1, param2. When using CMD param1, param2, these parameters will be passed to the entry point. We create the 15th folder about the instruction entry point. As usual, we create a note file first. For the note, we just copy the step for making Docker from before. Don't forget to copy the Node.js express as well. We create a Dockerfile, then also copy the Dockerfile from before and some modifications. We change run to workdir in Dockerfile. Then set up entry point. Then add command instructions for host setup. Then we build the Docker image and the container. Then start the Docker image. We inspect the container to see the entry point results. MutliStage Build. When creating a Dockerfile from a large base image, the size of the resulting image will also become large. Therefore, it is recommended to use a base image that only includes the necessary components, rather than installing unnecessary features in the image. Docker has a feature called MutliStage Build, where we can define multiple build stages in a Dockerfile. As we know, at the beginning of the build process, we usually use the FROM instruction, and in a Dockerfile, we can have multiple FROM instructions. Each FROM instruction represents a build stage. The final build stage will be used to create the final image. Let's create the 16th folder with instructions for implementing a multi-stage Dockerfile. As usual, we'll start by creating a note file. For the Dockerfile creation steps, we can simply copy them from the previous instructions. After that, we'll change the tag name and container name to MutliStage. In this process, we will create a simple API service using Node.js, Express, and TypeScript. First, create a folder and initialize it with yarn. Then, download the required dependencies such as Express and TypeScript. Perform some configuration in the tosconfig JSON file by setting the outDear Toadist folder. Next, create a server. File with code to call a simple getAPI. Add script start and build in the package JSON file. Now, it's time to build the Dockerfile. In this multi-stage Dockerfile, we will use two from instructions. The first from instruction will use Node as a build stage. The steps for this stage are straightforward. We'll create a working directory app and copy the package JSON file to the app folder. Then, we'll copy all files from the Node.js project. After that, we'll run yarn build to build the project. The second from instruction will use Node with Alpine to reduce memory usage. We'll create the working directory app and copy the package JSON file from the first stage. Then, run yarn install and copy the build results from the first stage. Additionally, expose port 8080 and finally, run the command yarn run start prod. Now, it's time to build the Docker image. Build the container and start the container. After that, we can check the list of images using Docker image else. We'll notice that the image with the tag multi-stage has a size that is 80 smaller compared to a normal image. By following these steps, we have successfully created a multi-stage Dockerfile that optimizes the Docker image size significantly. In the future, we will be learning about Docker Compose,